Jonathan from Rain Brothers here, rainbrothers.com. This is a video that I have been wanting to make for a long time. We've been in business about 20 years. I've been personally in about 3,000 different cisterns in those 20 years. And I have seen a lot of mistakes, and I've also seen some things that actually worked pretty well. And this is going to be a comprehensive analysis of all that information to give you what I think is the perfect cistern design. So let's go through it all one by one to see what doesn't work and what really does work well when you're designing a rainwater harvesting system. The first problem we see in cistern design is people who make their cisterns out of concrete block. And of course, concrete block is different than poured concrete. But the problem with concrete block is that it has hollow spots in the center of the block or offset from the center of the block. And concrete inherently is porous. It will allow water to pass through. So you have to coat the concrete with a waterproofing cement like our Master Seal 581, used to be called Thorough Seal, something like that, to keep water retained by the concrete blocks. But once that seal wears out in, let's say, 20 or 30 years, and if you're not keeping up on preventative maintenance, it is almost impossible to establish a seal again on concrete block. And the reason for this is once that block starts to hold water in those hollowed out cavities, it will seep into the cistern, in and out of the cistern, and it'll be like cheesecloth. That water will constantly be flowing. And sealing a tank that has water constantly flowing is a very difficult job. You see here that we're trying to patch a water spot. It's coming into the tank. We'll use a hydraulic cement, a dry powder. We'll apply pressure on that water spot. Maybe we can get it to stop leaking there. But as soon as it stops there, it's just going to push out the next spot of least resistance down the wall. It'll just move that leak to a different spot, and we have to start all over again. We've tried to drill relief holes in the concrete block where we allow the water to escape the block, drain it out, and then seal it up. That works for a little bit, but because each of these concrete blocks that make up the cistern has a cavity like that, you really, in order to do this, you have to drill each and every block in that cistern, sometimes in multiple spots to get that water to drain out. And that's assuming that the other side, the outside part of the cistern wall, the exterior wall, doesn't have hydraulic pressure against that. Because if you have a spring or groundwater accumulated by that exterior wall of the cistern, it's just going to seep right back into those hollow spots in the block, and it's going to be an absolute nightmare to try to reseal. So stay away from concrete block if you're trying to build your cistern. And if you do have to use it, make sure you keep up on preventative maintenance and reseal that concrete tank every 10 years. Now, where concrete block does come in handy in designing cisterns is in building something called a nest or filter wall. And we see this in a lot of older cisterns that are two compartment tanks divided by a concrete block wall or a brick wall. And the reason for this is that the original design was you have your inlet water, roof water, coming in on one side of the tank, and then that concrete block wall acts as a filter wall. So again, because concrete block is porous, it will allow water to seep through it. As water seeps through, because that concrete is porous, it's also very refined. It will trap a lot of sediment. So it acts as a filter, pushing that water through to the other side, and that other side is what we call the clean water side, and that's where your pickup is going to be for your pump, or that's where your pump will be placed, in that clean water side. Now theoretically, this is a great design. You have a nice filtering capacity in that cistern that's going to prevent contaminants from passing through the cistern wall to the clean water side. And oftentimes when we see these old cisterns like this, it's on a tank that's 60, 50, 40 years old, and this is the only filtration they have on their rainwater harvesting cistern. They don't have any pre-filters, any roof washer filters. They also don't have any inside filters. Now, that becomes a problem because eventually that block, the mortar joint is going to wear out in that block. And what once was a fine sediment filter, a refined block filter, is now more coarse. And it's going to allow debris to that other side. It's going to allow bacteria from that other side. It's going to allow any number of contaminants. And oftentimes what we see is a very dirty inlet side, and then we see almost as dirty of a clean water side because it really doesn't filter everything out. We still see silt accumulation on that clean water side. We still see buildup, and a lot of times people will put that block wall up and then they'll drill relief holes so that equalization between the two sides happens more quickly and you don't get any extra force on one side of the wall than you do on the other. So again, it's a good idea in theory, but you still really need a good pre-filter if you have a cistern like that, and you absolutely need indoor filtration with a system like that. You can't rely solely on the porousness of concrete block. This brings me to my next point, and that is when you're designing a cistern, a rainwater harvesting cistern, you want to make sure you're accounting for the life of the cistern, and that means planning for how that cistern is going to be cleaned. We have gone in any number of old cisterns to clean them, and they have been an absolute nightmare. They'll have cutout windows like this where you have to crawl into the cistern to get inside, and they have limited access for equipment. Let's say the window or the manhole is just too small. We can't get our ladder in, we can't get equipment in, we can't stand up in it. We need to be able to cleanly access the inside of the cistern with a good-sized manhole, which is going to be at least 24 inches in diameter. And we need to do it in a spot where we can get the surrounding area dirty, because when we go out to clean these cisterns, if there's not a good pre-filter on this tank, that area is going to get very dirty despite our best efforts, despite the number of tarps we have down around the cistern. There is a lot of silt, and silt is not far removed from oil. It's very dark, very dirty, just kind of staining things that you really want to account for. Now, some of the worst designs we see are cisterns with, as I mentioned before, a cutout window that we have to crawl in, that we can't get a ladder in. There's no physical way to get a ladder into a window if it's cut out from the side of the cistern. And if there is a way to get the ladder in, then you can't get a person in and the ladder in. So you really got to think about access. The other thing that we see a lot is cisterns that are shorter than the average person. And I don't know about you, but I do not like working on my hands and knees or with my back bent inside a dirty, small, dark space. It can be very demoralizing to work in something like that. So you want a cistern that is at least 6.5 feet tall, that you can comfortably stand up in, comfortably move around, and get that sediment out of there. Now, the other mistake that we see in cistern design is cisterns that have an access inside the house. We've seen them in very nice rooms, right in the middle of the room, where someone has to literally tear up their carpet to get into the manhole, and then we have to figure out a way to pump water out of there without, making sure our hoses don't have any punctures in them, and that we're getting that water discharged safely without getting water damage in the house. Or a lot of times we have to haul up bucket by bucket out of the cistern, and we don't want to splash that bucket around inside a house. You don't want a cistern that's going to require kid gloves to clean, because it's just going to be that much more expensive to maintain, and you're going to have that fewer of contractors willing to take that project on. So put that cistern out in a green space. Put it in the backyard, front yard, side yard, but make sure it's outside, away from the beaten path, in an area that you don't care if it gets temporarily dirty. Now, what about the type of tank? What works and what doesn't? Now, a lot of times there are some misconceptions about plastic and concrete tanks both. A lot of people ask us straight up, what is your preference? And unfortunately, that answer depends on a lot of factors. Now, there are upsides and downsides to plastic tanks and concrete tanks. With plastic cisterns, you want to avoid the old style plastic tanks that are just a hollowed out spherical vessel that is a ribbed vessel. These would be like the old Norwesco tanks, frankly most plastic tanks on the market. The reason for that is those old just spherical vessels that are simply a holding tank, once you put those underground, they are very buoyant, and you really have to account for that buoyancy unless you want that tank potentially floating up someday. And obviously you don't want that. Now, the reason they're so buoyant is that they're flat on the bottom and hollow in the middle, and any groundwater pressure, if that tank drains all the way down and it doesn't have sufficient coverage on top of the tank, any groundwater pressure is going to try to push that tank up. And it may not pop it out of the ground, but it could elevate it or raise it an inch or two, which can be problematic. So you really have to be careful with that. Now, the good news is that Norwesco, within the past decade, has come out with a line of low-profile plastic cisterns that are absolutely excellent for underground storage. And the reason that they're so excellent is that they have hollowed out cavities in the center of the tank that not only act as support posts for the tank, support columns rather, but they allow for any underground hydraulic forces to disperse through that center column, and it allows for less buoyancy on the bottom of the tank. There's a relief column essentially for that hydraulic pressure so that it's not pushing up on the bottom of the tank, but it's going around the sides of the tank and through that center column to relieve the pressure. We've installed these low-profile plastic tanks for easily a decade. I have never had any problems with them. They are fantastic tanks. They hold their shape. Some of the old style cisterns that were just an empty vessel, if you didn't backfill correctly, or even if you did sometimes, that top would tend to compress and squeeze that top out of shape a little bit, enough so that the riser connected to the top of the tank would not go out of shape in the same way, and your tank would have an oblong riser hole, and the riser addition, the manhole extension, would still be round, and it could create a leak point in that joint. And again, with the low profile tank, if you install it to manufacturer specifications, if you use good backfill around it, if you use flowable, I like to use a 411, it's a paver base, a crushed limestone. If you use a good compactable base in that support column and around the tank, you will not have any deformity and you'll have a very good installation. Now, there are other plastic tanks on the market. Roth makes a good plastic tank that is an empty vessel, but they have a stronger exterior shell. It's a different type of plastic, and they manufacture the plastic differently. The Roth tank is a good tank. It's an affordable tank in a lot of ways. There are also tanks that are two-piece plastic tanks where you actually have a gasket with clips to hold the plastic tank together. Now, I don't have any personal experience installing a tank like this. I have cleaned a tank like this. As you'll see from this footage, I am a little nervous about that joint. Obviously, if you can avoid a joint, it's best to, in my experience. Sometimes the joint is unavoidable, but with a plastic tank, I don't know if it's worth getting a two-piece tank and piecing that together, because if you're not an experienced installer, it's hard enough to learn how to do these cistern installations well. But if you're having to add a gasket and clips into the mix, the chance for failure is just that much higher. So I really steer people, if you're getting a plastic cistern, there's nothing wrong with that option, but I steer people into getting one of the low profile Norwesco cisterns. And incidentally, we carry those tanks. I'm not saying that as a selling point. We carry them because they're good tanks and we know they're good tanks. We have access to other Norwesco tanks that we do not put on our website because I don't feel as confident about that installation as I do with the low profile cisterns. Now, what about concrete tanks? What about precast concrete tanks specifically? Precast concrete, that is our favorite, but we have a caveat with that. We manufacture our own line of precast concrete cisterns, and we manufacture them to be cisterns. We're not taking a septic tank and trying to fit it as a cistern. We're making a tank that is specifically designed to be used for storage of drinking water. Now, what differentiates our precast concrete tanks from other precast concrete tanks is that ours has a varying wall thickness on the side walls between 4 and 6 inches, or we can make a full 6-inch wall for, let's say, traffic bearing applications. Our ceiling and floor are also full 6-inch, and the whole tank itself is cast with a steel rebar cage. We're not using fiber mesh as the reinforcement. We're not using wire mesh as the reinforcement. We're using steel rebar cages for the structural reinforcement on the tank. The other thing is we're casting our tanks using a 5,000 psi or greater concrete mix, which is technically inherently rated impermeable. Anything less than 5,000 psi and your concrete is going to be porous, and you'll have to coat it with a waterproofing cement. Our tanks are designed watertight right out of the gate. We also have a few features in our cisterns that are a good overall design, including a sump basin. So when you go to clean out the cistern, you can put your submersible trash pump in that sump to get more of the water out before you start vacuuming it. We also have inlets and overflows off to the side of the tank, and we can angle them away from the pump side of the cistern so that we're keeping the sediment secluded to the back end of the cistern and keeping the clean water towards the front end right underneath the manhole. Our cisterns are rated for drinking water, NSF certified, Ohio Health Department certified. So they're really great. Now, you may not be close to us. You may not be within our delivery or flatbed trucking zone for receiving one of our concrete tanks, and that's okay. You might be able to find a good concrete tank closer to you. The things you want to ask for are, what is the wall thickness? You really want a minimum of 4 inches, and ideally that 4 to 6 inch wall thickness. The other thing you want to ask is, what are they using to reinforce the tank? Are they using fiber mesh? Are they using wire mesh? Are they using rebar? Of course, our preference is rebar, but there's nothing inherently wrong with the other things. You just want to be informed as you're comparing apples to apples and knowing what kind of tank you're getting. The most important thing is knowing what the sealant is that they're using, because this is a common misconception. Any precast tank has to be a minimum of 1 joint. So it has to be a minimum of 2 pieces. Like our 5,500 gallon cistern is a 2-piece tank. The reason for that is you can't cast a single piece tank because you can't remove the forms. The size becomes unmanageable for a truck loading a truck. But mainly you can't release the forms and ship a single piece tank. It just doesn't happen. The logistics make it much easier to section off the tank into multiple joints. And to seal that joint, you want to make sure you're using a potable grade mastic sealant like Conceal NSF certified corn-based mastic sealant around that joint so that your drinking water is not exposed to harsh chemicals. Now, if you're going to a local precast company, you're going to want to ask them what they use to seal that joint and if they can use the green potable grade mastic sealant to seal that joint. Don't use the black sealant. That is a tar-based sealant and it is not good for drinking water. You want the corn-based version. And if they do a lot of precast tanks, then they're going to have access to that green sealant. So make sure you ask that question. And then make sure they're not, again, trying to force you into just using a septic tank for your cistern, because the two are not equal. While there is some crossover, you want to make sure that they're protecting and thinking about your drinking water storage and giving you a good product. So what's better, concrete or plastic? It really depends on the situation that you're in and the type of installation that you have. If you're in a remote area and you have a very steep driveway or you have very limited access, you're not going to be able to get a crane truck or a flatbed semi at your property to get a concrete tank in there. You will, however, easily be able to get a plastic tank into the site. So accessibility is the top factor for determining what is better between concrete and plastic. So what about poured concrete? Is that a good option? The answer is yes, it can be, although we've seen a lot of people try to go down that route and hire a contractor who they thought could pour them a cistern, only for it to turn into an absolute disaster. You really have to have someone who has a lot of experience pouring concrete cisterns or at least concrete vaults to make sure that they can get you a usable tank. What we see a lot with poured concrete cisterns is people pouring them with their house foundation. Now, on the surface, this is not a bad idea. It certainly saves money because you're already excavating for your basement. You're already pouring concrete walls for your basement, so why not just excavate a little beyond the basement wall limits and pour some cistern walls too? Well, that's a good idea, except that the cistern wall elevation is going to be equal to your basement wall elevation. And for you to wrap downspout drains around your house, around into the cistern, let's say you're draining around the backside of your house, going around, sloping everything down to drain into the cistern. By the time that inlet reaches a poured cistern that's equal to the elevation of your basement wall, your inlet's going to be 2-3 feet down from the top of the cistern. So while you might save money initially, your tank is only going to be able to hold 2/3 of its intended capacity because of the way that pipe invert or pipe elevations play out. So you're not getting the bang for your buck. You're not getting full capacity out of a poured in place cistern that shares a wall with your basement. The other thing is, if you're sharing a wall with your basement and you're using poured concrete, eventually that concrete will have to be resealed and waterproofed, and you may not know when that day comes until it's too late and water starts leaking into your basement. Now, in some cases that's okay because you have a floor drain right outside your cistern wall in the basement by your filtration and pumping equipment, and the water just goes into that floor drain, no problem. You see that the wall is leaking, you go in there and reseal it, no big deal. For others, if you have a finished basement on the other side of that cistern wall, you could come into some real issues, and it's not a fun situation to be in. Now, the last thing I want to talk about in regard to cistern design is size of the cistern and layout of the system itself. The temptation for a lot of folks is to design a really large system. And yeah, okay, you have reserve water in case of drought. I get that, no problem. But there is such a thing as designing a system that is too big. We had a case in Kentucky where we were working on a cistern for someone, and they had a poured-in-place cistern in their new build. And this poured-in-place cistern was absolutely enormous. It was easily a 40,000, 50,000 gallon tank. And keep in mind, we're in an area that gets regular rainfall. In an average year, we're getting 36 inches, about 3 inches every month. So we can count on a pretty regular rainfall. We don't have to store large quantities out for a dry season or extended periods of drought. Sure, we get that on occasion, but overall, you play for averages, not exceptions. So in this particular case, the cistern was so big that this homeowner actually wound up developing a leak in the cistern. And you can only imagine how difficult it is to clean out a cistern that has such a huge footprint. Because you can't just stick a pump in there and pump out all that water. You're going to have, even the best pumps will leave a ½ inch of water all throughout the floor. So if you have a cistern floor that is 40 feet by 40 feet, my gosh, we have to vacuum up that ½ inch spread across that footprint. Mix that in with some sediment buildup, and you have hours and hours spent just getting the water out of the cistern to get it clean to a point where we can try to seal it. Then we have to find the leak. And in a tank that size, it's nearly impossible to pinpoint where water is coming in. So we have to coat that entire tank and hope that we get that leak. And let me tell you, that's an expensive repair for something that didn't need to happen in the first place. Our preference in designing a cistern is to scale down. Get to where you're just putting in a cistern to meet your monthly needs plus a little buffer. Sure, you may have to haul in water, but you can truck in several hundred loads of water before you pay for another cistern. So our main focus in designing a system is looking at how many people are in the household, what their average water usage, what the roof can give us as it sheds water from a rain event. And in most cases, in the Ohio region at least, and in our specialty region, our service region, that's going to be about a 5,500 gallon tank. And that tank will get an average family of 4 or 5 through 90% of the season. And we do say maybe factor for a load or two of water every year, but at $80 a load for a couple thousand gallons, again, that's worth it. If you double the capacity of your system, sure, you do have reserve left over, but now you're just increasing what you have to clean, increasing what you have to maintain, and you're increasing the initial investment of the system itself. Now, for those who want to be resilient and who never want to haul water, I get that absolutely. In that case, we do recommend doubling the size of the initial estimate. So here in the Ohio region, that would be, instead of a 5,500 gallon system, it would be an 11,000 gallon system. And there is benefit to having 2 tanks in your setup. That actually is a very good design. What we do in that case is we separate the tanks so that the incoming roof water, your rainwater leaders or your downspout drain into one tank, and then there's going to be a pipe that connects a second tank. That pipe is going to be set up a couple inches, and it's going to be tying the bottoms of the 2 tanks together. With the 2 tanks tied together at the bottom, except for it's going to be elevated a couple inches again, that's going to equalize both the tanks, so they'll each hold approximately the same volume of water. But in the second tank, that's where we're going to place our pump. So our downspout drains, again, are going into tank 1. Our pump is going into tank 2. And what that does is it creates a sediment zone in the first tank so that any sediment coming off the roof, getting through the roof washers, is going to accumulate in the bottom of the second tank. And then it's going to come up to that equalizing pipe, come up a couple inches, drain into the the first tank, that's going to give us our cleanest water for that pump to draw into the house and give you a good clean supply for your house. So let's recap. Don't build a cistern out of concrete blocks. If you're wanting to put in a tank for your home, think about your access. If you have good access, a solid driveway, and you're in proximity to a good, reputable precast concrete supplier, think about a concrete tank. Ask questions about that tank, how it's manufactured, what the wall thickness is, how it's being reinforced, and if it's being made to potable standards. If you're in a remote area and you're worried about big trucks being able to get in, go with a plastic tank. Think about a low profile tank with a good solid center support and hydraulic relief to alleviate groundwater pressure. When you're laying out that cistern design, make sure you're thinking about that cistern in terms of future maintenance on the system. Make sure that access is outside, is large enough for someone to get in with a ladder and a vacuum. If you have two tanks tied together, make sure that someone can get in safely to both tanks. Just think about future maintenance on the system when you're laying out your cistern. And finally, think about the size and capacity of your cistern. Don't be fooled by the temptation to over-engineer or over-plan the capacity of your cistern. Try to narrow in on what your needs are. Look at the rainfall data. If you don't have extended dry periods, then try to hit just a smaller system, because in the case of rainwater harvesting system, smaller systems are easier to maintain, they're easier to clean, they're easier to monitor, they're easier to fix, and they're cheaper. So if you can hit all those points, that's a great thing. And as always, if you have any questions about this, please visit us at rainbrothers.com, or better yet, go to our new cistern forum, which is going to be cisternliving.com. Go on there, ask questions, ask the community, share your experiences, and let's try to hit the perfect cistern install for your house. Thank you so much.